Yes, hi guys. Now let me describe that what is the nth derivative of a function, okay, for the specific value of x. What is the specific value of x or specific value of x? That means that in certain cases we are not able to find out the general value of yn, alright, or nth derivative of a function. However, in such cases we are able to find out that what is the value of yn or x equal to 0. Okay, or in such cases we will find out the value of that function at x equal to 0. This is known as specific value of x. That means x equal to 0, we have to find out what are the different values of yn, y1, y2, y0, etc., or yn 0. That means at x equal to 0. In such cases, we have to find out that what is the possibility of that function at x equal to 0. What is the value of that function at x equal to 0? So these are some questions which I have taken here. I'll clarify that how this kind of questions are solved. Okay, and I've taken these 7 questions from online queries of my students or from the queries of the students in the class as well. Okay, so let me clarify one by one. So let me illustrate this kind of questions here. So first let me take the first question. For some specific values, it says that find yn 0, that means nth derivative of this function y equal to sine inverse x when at x equal to 0. What is yn value? Okay, or nth derivative of this function when x equal to 0. So here we are given that y equal to sine inverse x. Then we have to find out nth derivative of this function at what is the value of this function at x equal to 0. Okay, for y and 0, that means at x equal to 0. So let me solve it one by one, and then applying Leibniz theorem here again, as I have explained in 33rd lecture, what is the Leibniz theorem and how the questions are solved. Similarly, we will apply the Leibniz theorem here also to find out the nth derivative of this question of these functions, and after that we will find out what is nth derivative at x equal to 0. Okay, so let me differentiate this function. Differentiating it, let me take first equation, and differentiating it with respect to x, we get here it is y1 is equal to sine inverse x, derivative of sine inverse x is 1 upon under root 1 minus x square. Alright, and after cross multiplication we get under root 1 minus x square into y1 equal to 1. Now squaring or differentiating it again, this is, let me take second equation. Now differentiating it again, we get, or again differentiating with respect to x. This is again means with respect to x. So this is under root 1 minus x square as it is. Y1 differentiation of y1 is y2. Alright, plus now y1 as it is, derivation of this is 1 upon 2 1 minus x square over half minus 1, that means minus half, into derivation of this 1 minus x square, because 1 minus x square is not x. We have to differentiate it again. It will be minus twice x, because 1 0 derivation of 1 is 0, and minus x square means minus twice x. Okay, and this is equal to derivation of 1 is 0 equal to 0. Now let me further solve it. This is under root 1 minus x square into y2. This is minus sign, but minus twice and 2 to cancel out. So it is minus x into y1 oblique 1 minus x square under the square root, because this is half minus half power, equal to 0. Now after cross multiplication or multiplying by under root 1 minus x square in these two terms, okay, or in this left hand side and right hand side, we get 1 minus x square into y2 minus x y1 equal to 0. Okay, so this is now the second derivative, third equation. Let me take this. Now differentiating it nth time using Leibniz theorem. So we will get the nth derivation of this question. Let me write it here. This is by1, value of by1, this is by2, equation of derivation second derivation of this equation. So second, let me write this equation here. This is 1 minus x square into y2 minus x y1 equal to 0. This is third equation. Okay, now let me write it. Now finding the nth derivation of this with the help of Leibniz theorem. So using Leibniz theorem, the nth derivative or nth derivative of this, the nth derivative of this equation, of this third equation, let me find out. So there are two steps here. So dn of 1 minus x square into y2 is equal to the derivation of first step. This one is 1 minus x square as it is, v as it is. This is first un, that means you are taken y2, so this is n plus 2. Okay, plus nc1, that means n into this 1 less, and derivation this is yn plus 1. Now derivation of this is v1, this v, so we have to write here v1. Okay, nc1 into u n minus 1 into v1. v1 means derivation of 1 minus x square, that means minus twice x. Okay, then plus nc2, that means n into n minus 1 factorial divided by factorial 2 nc2, value of nc2 into yn, but further one lesser than this is yn plus 1, this is yn. Now derivation of minus 2x is minus 2 only. Now next terms will be 0, so only 3 terms. Now let me write it again. This is 1 minus x square into yn plus 2. This is minus twice nx into yn plus 1. This 2 to cancel out, but minus sign, minus n into n minus 1 into yn. This is fourth equation, let me take. Okay, this is fourth equation. Now derivation of second step, nth derivation. Now nth derivation of minus x by 1 will be, this is y1. So nth derivation of y1 will be yn plus 1. But right below this n plus 1, this is minus x v as it is. Derivation of u is un, that means yn plus 1. This is yn plus 1. Okay. Now next step will be nc1, but this is minus sign. Okay, let me write here plus. First nc1 means n into nth derivation of un will be un minus 1, that means yn only. This is below nth derivation, and derivation of minus x is minus 1 only. This is the fifth equation. Now adding these two steps, this plus this will be 0, because derivation of this and derivation of this minus n and derivation of this equal to 0. So left hand side is 0 on addition. Let me write here on addition. On addition, we get this is 0. Sum of these two steps is 0 because it's equal to 0. Left hand side is 0. Now this right hand side we are having only one step, which is having yn plus 2 term. This is 1 minus x square into yn plus 2. Now sum of these two steps, similar terms, because they are like terms. So yn plus 1 is another term, but minus sign. So let me take minus sign common. 2n plus 1 into x by n plus 1. Similar term by n plus 1. This is minus twice nx. This is minus x. Let me take minus x common out of the bracket, so 2n plus 1. Alright. Now this is minus sign with both. So here it will be n square within bracket. Now because minus sign I have taken common, so minus into minus will be plus n. I'm sorry, first will be negative and one will be positive. So this is plus minus minus. Okay, first positive, this is minus n into yn. Minus and plus n cancel out. This is minus n square into y. And now let me write it here in the series of this. Okay, this is third equation. This is fourth, let me take, or sixth, whatever. Sixth, let me take. 1 minus x square into into yn plus 2 minus twice n plus 1 into yn plus 1. This is minus n square into yn equal to 0. Now we have to find out what is the value of these functions, nth derivation of this, or first derivation, or second derivation, okay, at x equal to 0. So at x equal to 0, the values from first, second, third, fourth, let me take this fourth again, okay, the values of, okay, by at 0, by 1 at 0, by 2 at 0, by n at 0, etc. Okay, from first, second, third, first, second, third, and fourth, we get. Now, if I substitute here 0, x equal to 0, sine inverse x 0 is for 0. This is 0 only. So y 0, 0, y1. This y1 is 1, and y1 at x equal to 0. At x equal to 0, if I substitute x 0 here, 1 upon 1 will be 1 only. Y1 is 1. What is y2 then? Y2 is this equation. Here x into y1 0, because x is 0. So y2 at x equal to 0 is 0. This is 0. Now in the fourth one, yn plus 2, let me write here n plus 2 first. At x equal to 0, this is 1 into this. This is 0, twice nx into x was here. So this x is 0, because here it was x, twice n plus 1 into x. So this x, when 0, this is 0, this term will be there. This is equal to minus, equal to plus n square into yn. Because this minus sign is to be taken to that side, so it will be positive. Okay, equal to sign. This is equal to plus n square into yn. Okay, so this is at 0. But here we have to find out by and 0. So now let me substitute these values. Let me find out this here. Okay, so applying these values, what we see that for odd number terms, for odd values of n, let me write here. If I substitute n equal to n minus 2, that means yn at x equal to 0 equal to, in this last equation. So n equal to n minus 2, that means yn minus 2 plus 2, that means yn at x equal to 0. Here it will be n minus 2 whole square into yn minus 2 at x equal to 0. This is the equation obtained from this last one. So at x equal to 0, this is the solution. But now we see here that by to 0, even terms are 0, value of even terms will be 0. Only odd terms will be there. So let me write here for even terms. When n is an even number, n is an even number, let me write here. N is an even number. Like 2, 4, 6, etc. and up to n minus 2. N minus 2 we have to substitute here. So last term is n minus 2. Okay. So if I substitute these values, then what will be there? So yn at x equal to 0 will be n minus 2 whole square, n minus 4 whole square, n minus 6 whole square, up to, this is 2 square, 4 before that 4 square will be, and last step will be by 2. This is by 2 at 0. But by 2 at 0 is 0. So this, if I substitute 0 into something, is 0. So this is 0 into, or n minus 2 whole square, n minus 4 whole square, n minus 6 whole square, up to 2 square into 0. This is equal to 0. So for even terms it is 0. Now for odd terms, y1, 0 is 1. So that I have to use for odd terms. When n is an odd number, if I substitute an odd number, that means n equal to 1, 3, 5, 7, etc. up to n minus 2. Here also we have to substitute n minus 2. This is by n 0 equal to again n minus 2. Here n is odd number. Okay, so this is n minus 4 whole square, n minus 6 whole square. So this is equal to, right, n minus 6 whole square and up to, this is 3 square, 1 square, and by 1 at 0. By 1 at 0 is 1, as I have just expressed. So it is 1 into this. So n minus 2 whole square, n minus 4 whole square, n minus 6 whole square, up to 3 square into 1 square into 1. So this is the series. So 1 square, 3 square into n minus 2 whole square up to, with decimals, 3 dots, and after that n minus 4, n minus 6 whole square, n minus 4 whole square, okay, and up to n minus 2 whole square, etc. These are the values. If I write from this n minus 2 onwards, the last one will be 1 odd, starting from 1 square, 2, 3 square, and so on. And for odd numbers, the value is this. So this is the value of yn at x equals 0 in case of first equation. Now let me find out the other equations, other questions. Let me solve. So first question was at yn equal to 0, the value was that series. Okay, now let me take the second equation. Second question, sorry. Second question says that if y equal to this, very interesting, y equal to log of e, this is of whole square, okay, x plus 1 plus x square root and the whole square, right. Then find yn 0. Again, value of yn at x equal to 0, special value of n. So in this case, if I find out the derivation of first y, I have to find in similar fashion with the help of Leibniz formula. I have to find out nth derivation of this, first, second derivation, then nth derivation with the help of Leibniz formula. So similar fashion, then we will find out yn 0. Okay, yn at x equal to 0. So this is, let me differentiate this. So differentiating it with respect to x, we get y1 is equal to, this is power 2, so 2 will come before, this is log of e, within bracket x plus under root 1 plus x, this is plus x square, whole nothing, now into, now derivation of log of x, that means 1 upon something, 1 upon the same whole value, x plus 1 plus x square. But because this is not only x, this is x plus under root 1 plus x square, so we have to differentiate it again. Derivation of this, let me write here, ddx of x plus under root 1 plus x square. Now this will be twice log of e x plus under root 1 plus x square, same. Now derivation of this will be 1 plus within bracket. Now square root, sorry, this is half power, so half power will come before 1 plus x square. Power will be minus half because half minus 1. This is differentiation we have discussed up to now. Okay, so simple derivation. Now, because 1 plus x square is not x, so by function of function method it is twice x, derivation of this, and divided by x plus under root 1 plus x square, this whole value. Now let me solve it further. This is log of x plus under root 1 plus x square. Alright, now this is now as taking LCM, this is 2 to cancel out. So x upon this is 1 plus x upon under root 1 plus x square. In the numerator, the denominator we have x plus under root 1 plus x square. Okay, now taking LCM in the numerator, we will have this under root 1 plus x square here plus x, so similar term will come up. That means twice log of e x plus under root 1 plus x square. Alright, this is x plus under root 1 plus x square in the numerator divided by, let me write this under root 1 plus x square, this was LCM with the multiplication to this. This is 1 plus under root 1 plus x square within one bracket, in another bracket this one, x plus under root 1 plus x square. So this is similar term, cancel out. Okay, now if I take this under root 1 plus x square to this side, it will be under root 1 plus x square after crossing into y1, this is y1, value of y1. Okay, so y1 into this LCM, take to this side, is equal to twice log of e within bracket x plus under root 1 plus x square. Now if I square both these sides, so squaring both sides, so squaring both sides, we get both sides, squaring both sides, we get, squaring on both sides, we get, it will be under root 1 plus, sorry, only 1 plus x square, this is 1 plus x square, into y1 square, equal to 4, into square of this whole, this is log of e, x plus under root 1 plus x square, whole square. Now this whole square, log of x plus whole square is y. So I can write it as 4 into y. Okay, so this is the simplification of this equation. Let me write it here. So final first derivation of this, we obtain 1 plus x square into y1 square equal to 4 into y. Okay, 4 into y. Now square or differentiating further, differentiating both sides now, differentiating both sides with respect to x, both sides with respect to x, we get, so this is 1 plus x square as it is first function. So differentiation of second is twice y1 into y2 equal to 4 by 1 only. I'm sorry, one step is left over because I have not completed this by product method. Plus, now y1 square as it is, differentiation of 1 plus x square is twice x is equal to, here it is 4 by 1, because differentiation of y is by 1. Now dividing this whole equation by twice by 1, dividing this whole equation, dividing by twice by 1, we get, if I divide this whole equation by twice by 1, which is common, so we will get, this is, let me take second equation, this was the first one, dividing by twice by 1, here we get 1 plus x square into y2 plus, this is twice x, sorry, x into y1 only, got twice by 1 cancel out, equal to 2 only. So twice by 1, if I divide this by 1 cancel out, and will be 2. So this is, let me take third equation. Alright, now differentiating this, whenever we come up to second derivation, then we differentiate by Leibniz theorem, using Leibniz theorem. Using Leibniz theorem, another derivation of this, another derivative of it using Leibniz theorem. Using Leibniz theorem, we get, so differentiation of this first step plus second step equal to derivation of 2 will be 0, right hand side will be 0, but this another derivation of this. First let me take first step, this is 1 plus x square into y2, which is equal to, now this 1 plus x square be as it is, differentiation of yu, that is y2 nth time, will be y n plus 2, okay, plus, now nc1, Leibniz theorem we have to remember, this is nc1, that means n into y n minus 1 differentiation of y, n plus 1 only, 1 lesser than n plus 2. Now derivation of this is v, so v1 will be twice x plus last step will be, because twice x can be further differentiated. Okay, we always assume v the algebraic function or polynomials as v1, so this can be differentiated further, and finally it is 0. So second next derivation will be n into n minus 1, because nc2 upon factorial 2 into yn into derivation of twice x is 2 only. Next step will be 0. Let me write it after simplification. We get 1 plus x square into yn plus 2, okay, plus twice n x. This is yn plus 1. 2 to cancel out. This is plus n into n minus 1 into yn. Okay, this is okay. Next step. Now second derivation of second step, which one? X by 1. So derivation of this, nth derivation of x by 1 positive. So after this below yn plus 1. This is x into yn plus 1. Next step will be n into this is x by 1. So this is by n. Derivation of x is 1 only. These two steps will be there, and right hand side derivation of 2 is 0. That cannot be. Now adding these two steps, this and this. So finally we will get on addition we get left hand side 0, because the sum of these two and another derivation of this plus another derivation of this equal to 0. Read this one. These two steps, another derivation of this plus another derivation of this equal to derivation of 2 is 0, so left hand side is 0. Now sum of these two, that means this is only one step. This is 1 plus x square into by n plus 2. This is by Leibniz theorem plus. In the previous lecture, 33rd, I have described Leibniz theorem, how to find out nth derivation. So the similar fashion I am using here. Okay, so this is the second step will be addition of these two. This is twice n plus 1 into x into by n plus 1, because x twice n x plus x. So 2n plus 1 common, x common, so 2n plus 1 in the bracket, plus here it will be minus n plus n cancel out, so only n square, positive n square into by n. This n square minus n by n, so plus n by n cancel out, only n square by n equal to 0. Now let me write it here. This is third equation. Okay, so this is third equation. Let me write third and fourth here. So first third, 1 plus x square into by 2 plus x by 1 equal to 2. Okay, and the last step, this one is by 2, and this is the last step, another derivation of 1 plus x square into by n plus 2 plus twice n plus 1 into x into by n plus 1 plus n square into by n equal to 0. Okay, so this is total sum of these equations. Now let me find out the value of these nth derivation, first derivation, second, etc. at x equal to 0. Let me take x equal to 0. So at x equal to 0, the values of these equations, the values of y0, y10, y20, and yn0. All these values we have to find out from these equations. Let me, y0 is, this is not mostly used, y0. y0 is for the 0 plus 0, okay, sorry, 1 log 1 is 0. Here we will get 1 only, 0, 0 and 1. Log 1 is 0, so this is 0. y0 is 0. Now y1 at x equal to 0, y1 we can obtain from here. This is 1 into y1 whole square is equal to, because y0 is 0, here we have to use y0, right? So this is 0, this is 0. y1 is also 0. What is y2 then? Now y2, Here it is 0 but equal to 2. So by 2 at x equal to 0 is 2. This is only for even terms. For even terms, value of even terms, we have to find out the values. So now let me, and what is by n plus 2? We have by n plus 2 at x equal to 0 equal to, this is 0 because x is 0. So this term is 0, only this equal to minus n square into by n. By n, okay, it's actually 0. But we have to find out this by n. So substitute n equal to n minus 2. We will get n minus 2, that means by n only. If I substitute in place of n minus 2, here n minus 2 plus 2, that means by n equal to, at x equal to 0 equal to minus n minus 2 whole square. This is y n minus 2, okay, at x equal to 0. So this term we have obtained. Now let me find out at x equal to even, when n is even and odd. So for odd, every term is 0 because by 1 is 0. Only by 2 was 2. Here by 2 we have obtained equal to 2. By 1 was 0. Okay, so this we have to use. So for n, when n is even number, when n is even number and n is odd number, so for even terms only value will be there. So when n is odd terms, let me take first odd. N is an odd number. N is odd number, like n equal to 1, 3, 5, etc. up to n minus 2. So this will be yn at 0, this term, equal to minus n minus 2 whole square, n minus 4 whole square, and so on. The last step will be, this is with negative sign, so double negative will be here, so I have to write it here. This is minus 1 at the power n minus 1.2. So these are the half terms of this, n minus 1.2, total terms will be n minus 1. Okay, up to, this is the odd terms of 3 square, 1 square, this is by 1, 0, but by 1, 0 is 0, this one, this whole terms will be 0. So yn for odd numbers is 0. Is 0. Now what is even terms? Now let me write here for even terms. Yn for odd terms is 0. Now for even terms, when n is even number, when n is an even number, n is an even number, that means n equal to 2, 4, 6, etc. up to n minus 2. Here also we will take n minus 2, not a problem. So